Okay, in this video, we're going to go over the formation of ions. Before we do that, let's have a look at some of the core knowledge that we need to understand behind the topic. Okay, so we need to remember that atoms have no overall charge. And this is because atoms have an equal number of positive protons and negative electrons. We need to know that noble gases have got a stable electron arrangement. So this is shown here. Helium is 2, neon is 2,8, and argon is 2,8,8. What makes this stable is the fact they all have a full outer energy level. And atoms either try to lose or gain electrons in order to achieve this stable arrangement. And that's what we're going to look at now, is how they do that. So to help with this, this is a page from your workbook. And we're going to do a couple of examples on here to help you get into this kind of work. Okay, so we have got here sodium. I'm going to write down on the top that sodium, the information from the periodic table tells me it's got a mass number 23 and an atomic number of 11. So this is for the atom side. So protons, from this information, it has 11. Neutrons is the difference, remember, between these two numbers. So 23 take away 11 is 12. And this has 11 electrons because core knowledge tells us electrons have to be the same as protons. In terms of arranging these electrons, then 11 electrons, we have 2 in the first, 8 in the second energy level, and 1 in the final energy level. So this arrangement is not stable. This is not full. How's it going to achieve a full stable energy level? It's going to lose this electron. So if it loses that electron, it did have 11, it loses 1, it then becomes 10. Protons will be the same, so 11 at the beginning as an atom, 11 as an ion, and neutrons stay the same as well. 10 electrons means the arrangement is 2,8. As you can see, this is now an outer energy level that is full. The formula of the ion, now remember, we have got 11 positives and 10 negatives. That means overall it's going to be positive by 1. There's one more proton than electron. That's the first example. Let's try another one. So here we'll do magnesium. So to help us with magnesium, we need to know some information from the periodic table. And the information tells me that magnesium is 24 mass number, 12 is the atomic number. So atomic number is 12, so that's the number of protons. The difference between the two is the number of neutrons, and electrons has to be the same, so it is 12 electrons because it's the atom. How do you arrange these 12? 2 in the first, 8, and then 2. There's our 12 electrons. Again, this is not stable. It needs to lose these 2 electrons in order to become stable. So if it loses these 2, that's going to take it down to 2,8, which is 10. It's still going to have the 12 protons and 12 neutrons it had. These 10 electrons are arranged to 8. And remember, here are our 10 negatives. It's got 12 positives. When you put these together, overall, there are 2 extra protons in there. It's lost these 2 electrons, so it is a 2+ ion. Let's look at some of the negative ions. So we'll do the oxide ion, which comes from oxygen. So oxygen on the periodic table is 16,8. Okay, let's have a look at this. So this tells me it's got 8 protons. The difference between the two is still 8, and the electrons have to be the same as protons. 8 electrons arranged to 6. This is not full, it's not stable. How's it going to become stable? Well, this time it's going to gain 2 electrons. So if it gains 2, it did have 8, it becomes 10. It still has 8 protons and 8 neutrons. This arrangement for the ion is going to be 2,8. And we now can look at the charge on this, and 8 protons that are positive and 10 negatives means there's 2 more negatives. So it's going to be O2- as the charge on the oxide ion. We'll do one more. Look at chlorine. Chlorine, we're going to take one of the isotopes. We're going to take chlorine 35. Okay, so 17 is the atomic number, so there are 17 protons. The difference between those two numbers is the number of neutrons, which is 18, and electrons has to be the same, which is 17. Arranging that, we've got 2, 8, 7, so 17 electrons is arranged like that. This is not stable. This needs to gain 1 electron. So if it gains 1 electron, it's going to become 18 electrons, and these two will stay the same. 18 electrons is 2, 8 and 8. Be careful, 18 negative electrons, 17 positive protons. There is one more electron here, so it's going to be overall a single negative charge on the ion. You need to get confident with this and be able to understand this and work these out. There's more in the table now for you to try using examples I've done in order to support you with this work.